Thank you, Stefan and Lucas, for working on these figures over the week. Really thankful for that.
It's a pleasure. By the way, I've just sent you a paper with a different type of model, which also has two types of error neurons, but which is different model than Keller's.
No, I see.
They are bottom up and top down, instead of actually having you pass an error forward and an error backward.
Is it similar when Rafa Bogas has been pushing recently, or?
So the one from Rafa, if I remember correctly, the Whittington, right? He's just trying to put the predictive coding of doing backprop, right? So he's not really modifying the predictive coding, he's just operating it in two modes, like a true inferential mode, but then has a clamping mode in which there is a plasticity and pushes things, right? So it's weird because it's what do you consider error? Because error, like in an error as in backprop,
yeah,
propagates down in that model during the learning phase, and error as in prediction error propagates up during the inference.
I see.
Right, that is Rafa's proposed, if I remember it correctly. Okay, I haven't looked at it in a few years, but this is different, in which they try to have errors in different categories. It's a semantic learning model, and they have errors in different. They consider that you're going to have different levels of organization, and the pathway in which you do the error is somewhat different. So it's more like you've got a predictive coding going up and the predictive coding going down.
Yeah, I do think Keller has these. I've seen these in multiple places.
Yeah,
including a piece from Keller's and on a collaborator on Perspective 2 years ago. Yeah.
Was it cited? Because I looked in the paper for that and I did not find this described.
Yeah, we I think it's in the letter sections maybe, but we did discuss errors in both directions later on.
Okay, because I searched for this particular paper, which I've seen.
Oh.
Okay, I'll be happy to.
Maybe this one is not cited. That's right.
It's okay. Fine. There are way too many papers to cite everything, so it's not as if there is. Yeah. Okay.
Yes, that's true.
In the 2026 bioRxiv that they just put online in January, they refer to some related machine learning literature, or JPA, I think it's called. And,
yeah.
Maybe that's also an interesting reference to look for.
That's the joint embedding prediction. It's very similar in concept, right? But this idea, which is somewhat similar to JPA, was from biologists who were studying N400 in humans and things like this, right? So it was from cognitive scientists, and it was earlier when they actually proposed this. But yes, it's similar to LeCun's model for how to put these jointly.
Okay. Why don't we get started? And given that we are just discussing a figure today, it's possible that people trust us to do this. So this meeting is, we're planning to record this and post on YouTube. So please keep in mind, and if you see something that you want us to edit out, we can do that. Okay. Our meeting agenda for today is a follow-up from last week, where we discussed the graphical abstract and the figure 2 of the arXiv paper. So today, Stefan and Lucas are going to share a proposal based on on the discussion last week and some work that they did over the week. So maybe I wonder if is it better if Stefan start or Lucas start?
I can start.
You can start.
To quickly go through, because I have some cartoons.
Yeah.
To quickly go through a set of
So please feel free to share your screen.
Okay, so in here is the panel A slightly redrawn, very similar to what it is now, but the main difference is trying to clearly visually separate what is going to be within area and between areas connections. And to put generally, the point would be to have an emphasis of the type of signals which are passed through. One option which we discussed is potentially to change a little bit to make them more conceptual, to not focus so much on what happens within an area, but to have like a circuit and a separate cartoon which is presented for that. I would say that it's important to create in here the type of errors which are separated, and based on the discussion 5 minutes ago, we might want to include another element in which there are errors sent, just errors which are sent in both directions, but to include an option, for example, because this is going to be hierarchical, predictive coding, where you do have going to send feed-forward error and feedback prediction, but there can be a non-hierarchical version in which you send both in a lateral-like connections in which you send both errors and predictions. If you want to put those together in a panel, it would look something like this in a conceptual fashion. Could easily be redrawn such that inside it looks like this rather than that. So those are potential things for panel A to include. Similarly, the separation would be for a panel B in clearly stating what are the things which are communicated, and in here it's only described from the perspective of the hierarchical version, because the other one would be somewhat similar in concept, to have the idea that there are dual errors, both positive and negative, which are passed forward and backward. And for the dendritic, the fact that errors are not passed, which to me makes it somewhat weird, because that was one of the most influential part from Rowan Ballard, is that the things which are passed between are going to be predictions, but in here the way this is drawn is going the errors, but in here they're going to be predictions, potentially for if there is a part which is going to be with conceptual things. There can be the panels which follow with the microcircuit don't need 2 areas, and I think Lucas has some versions with that. So those would be the potential proposals for how this figure to look. Lucas, do you want to go next before we jump in discussions?
Yeah, I think that makes sense.
Any questions for Stefan or clarification? I think the addition of text in between area is really helping. I think it's important over the flow. So that helps. That's going to help clear the narrative. I agree.
Yeah. Do you see the presentation window?
I see.
Yeah. Okay. Perfect. So just for context, I just put the previous version here. And you saw in Stefan's proposals that especially panel A would become or would profit from being a bit more an abstract depiction and highlighting more the flow of information instead of depicting real synapses. I think that's also a proposal that Martin was doing last week. And so yeah, those were Stefan's proposals. I tried to incorporate this a bit with the style that we had previously. So this would be maybe a bit of a mixture where we have in A 2 areas depicted that have these classical hierarchical interactions, and then the non-hierarchical. I'm not sure about the naming here. Stefan used a different one with the lateral, because non-hierarchical it's not clear what is feedback and feed forward and so on. So this is, I'm really happy to adapt this. I just realized this right now. It was just copy and pasting essentially. But this could be a mixture. And here, these arrows, they do not go into these areas because it's really not clear. It depends, I guess, on the exact proposal where these things go. And of course, we could also have something that is more like this in A. So this is up for discussion. And what we could then do is show the microcircuit, also Stefan suggested. And here in C is a microcircuit that is in line with A. And since the way these areas are interconnected is depicted here already, I only showed one area and indicated the in and outcoming connections with these thicker horizontal connections. And then here we have the local microcircuit. And for the non-hierarchical, I had to choose essentially versions of this, and here I chose the one from the 2018 Neuron paper of Georg Keller, and it is essentially a version where, yes, so here I chose not to depict the connections, inter-area connections for the error neurons, because there is not really a clear proposal of how this would work. So here I only showed the non-hierarchical organization of the prediction outputs and inputs. And here again, we would have to see how to work with the names. I think in Georg Keller's work, they call this feedback and feed forward, or bottom up and feedback. We'd have to see. But this is essentially just showing that the microcircuit in this non-hierarchical case can look quite different. So you see the polarity, how this local prediction neuron interacts with the error neurons is sign inversed. And this would be one option we could show here, which has been quite influential in the literature. And then in E, we could have the dendritic one. And here, because predictions are biased forward and backward, there's not really a difference between the non-hierarchical and hierarchical only. I mean, it is different in the sense of where these connect to the dendrites, but because we do not specify all of these computations in detail, I wouldn't want to differentiate here different dendritic microcircuits, because also there's not really a hierarchical and non-hierarchical proposal out there in the literature as far as I know. So this last spot we could use for a legend. This is just a proposal how to put these things together. And of course, I mean, Benedict can, enhance the layout and all of these things, but we should discuss from the scope of the figure if we agree on these. And so looking forward to your thoughts.
Lucas, you have some question from Farzaneh?
Thanks, Lucas. A and B are very clear. I really like them. C and D, I'm trying to see if there's a way to make them less complicated by breaking them down into like two parts. Like, can we, I'm just talking as I'm thinking. So, but the idea is to make this C and D simpler. So I'm trying to see if there is like that part, the bottom gray part. Can we do it separately for the positive and the negative error neurons? So we just replicate it instead of showing both of them in one figure, if that makes sense.
Okay, so you're saying only
I'm
showing,
trying, my goal is to make this figure just like A and B, that they're very easily, like we can see them, we can follow them. then we get to C, and it's too many arrows crossing each other. So one way I'm thinking we can do it is to have that bottom gray part. I cannot move a cursor to show, but I guess you know which one exactly, this one. Just replicate it once under the positive error and once under the negative error.
Right.
Mm-hmm.
I mean, these are prediction neurons, so they have to integrate both positive and negative components.
So then is it possible to do it step by step, like show integration by positive, then information from positive, then negative, and then a third box says in A and B integrated? You see what I'm saying? So yeah.
It's a good point that these are pretty difficult to read. My feeling is that for the non-hierarchical, it kind of works because we neglect our incoming and outcoming errors, so to speak. So maybe we could split it to inter-areal and intra-areal connections as well. Just an idea, I don't know.
I wonder if, Lucas, if we could label those gray box, you know, positive circuit, negative circuit, and prediction circuit. You see what I mean? To help read the figure?
Yeah, we could for sure give these names here. Yeah.
I have E might belong on the bottom right. Is that right?
Say again, sorry.
The box E, shouldn't it belong at the bottom right, not the bottom left?
No, I think this is hierarchical.
Is it? Okay.
Yeah, because you get I mean, yeah, I know what you mean, but it's essentially shifting the arrow, so you get this one up here. So you have both error computations within the same area, but it's strictly speaking, it's the same flow of.
I see.
It's the same algorithm, essentially.
I mean, last week Martin suggested to have the error units in A and B be bicolor, like both yellow and red, and I think that seems helpful. I'm just curious, what do you think?
Yeah, so you're like splitting it in half or so, and then
just the two colors in it, so that we acknowledge that there are sign.
Yep. We could do that for sure.
Any other comments from the group? Stefan, do you like this figure? Or?
I love it. It's very much as a question. I actually think that it captures everything which we commented about for so long. So in the end, the problem which is there is that D is imprecise. But I think that's that's mentioned clearly, that D is imprecise, and it's intentionally imprecise because we don't know, and there aren't a very clear specific. That is, I dislike general imprecision, but I think that is a case in which it would be, I don't know if to necessarily put dots with a question mark in it would make it to be weird. I think that this works better. I'm just thinking out loud. I think that it's the best. And for Farzaneh, I fully understand that there are many arrows in there. It's just after spending hours trying to make this simpler, I can't think of an easy way if you want to describe it in terms of neurons. Because if you want to describe it in terms of modules, yes, it's very easy. But if you want to actually say, hey, that is a type of neuron and things like this, it's a spaghetti ball. no matter what at the end.
So how about, so the goal is to make this understandable to most readers. That's the goal. Because a lot of effort has been put into this figure, and I totally understand what you're saying, Stefan, but if it's not accessible to, let's say, 60% of the readers, then it's not working. So how about, I've seen that more people are doing this, that next to the letter of the panel, they write a few phrases that summarizes that panel. And I'm loving it because it's like I look at the figure and next to the panel, a few phrases says what's the gist of it. So would it work that for each of these panels, we have some summary like that guides, like when I look at panel D, so I can understand. So feedback prediction is going to the negative prediction error neuron, then from like something that guides my reading. So I'm just trying to brainstorm how we can make this more accessible to someone who didn't make this figure.
Are you suggesting for the text, right? I mean, the text will have to explain the figure.
It's not a detailed figure caption, what I'm suggesting. It's gist of the panel in a very concise way.
But in the manuscript or in the caption, we can add those step-by-step text, right? Where you want to add it in the figure.
Yeah, I was talking about the figure.
In the figure.
Like
maybe
next to
add
the
some,
panel. Not inside, next
maybe
to the panel.
some small Roman numerals or something that you then break down in the steps, right? So you write some
that's getting
in
closer.
C,
Yeah.
like 1, 2, 3, 4, 5, and then you just say, okay, one's this, two, and you can put them on specific connections, or
I see.
Perhaps.
shouldn't be too clouded, but something like this might work, right?
Yeah.
Just to walk through the network is what you meant, Fardane?
Yes, that's what I mean. And I think is this Venk? Am I saying your name right? Sorry.
Martin,
yeah, I think Venk is having
Yeah, exactly.
good thought
Just
here.
C would have like 3 numbers or something, right? 1, 2, 3 for the 3 gray boxes, and then you just explain what's going on there and how they're connected.
That's right. So it could be in the caption of the figure, right? Like
Exactly,
we refer to the numerals. I think that could work.
Exactly. So we can write the numbers here, and then the caption describes them.
I do agree that lots of people were confused with the Volvo's diagram, so I think it's definitely fair.
One possibility would be instead of numbers to name them, right? So the bottom box would be the prediction or
That's
state.
right.
And it would be negative error and positive error. Right, so if you just put the names above the box and then you describe, feed forward input comes into the prediction neuron, top down, or feedback, the feed forward error comes into the prediction neuron, the information or the circuit, which is passed between the two predictive errors, where it is combined with the feedback prediction. Or something like that. So
I actually, the more I think about it, I really like, is Venk your first name or last name? Sorry.
Martin, you mean?
Martin.
Yeah.
Martin, yes. So I really like that suggestion of 1, 2, 3, because that guides it, like we know how to go through it. Yeah.
I mean, it might be worth adding that to E as well, because in E we also have examples of positive, negative, and like the numerals, just to help like link those panels. Something we can iterate with Benedict, and he'll be clear. Okay.
Yeah.
Have we converged?
I have some remaining points about E, but we can come to that now.
Please.
So in E, the connection from the central neuron, well, the only pyramidal neuron to itself, to the negative error dendrite, is that supposed to be an outapse? Because in the model, that's just a leak current, right?
Mhm.
But
Yeah.
it's a bit strange to have a leak current actually going in the dendrite, because technically it's just, well, the leak current is everywhere, but it's because that's representing the negative, the leak term, right? But actually in the model, the leak term combines with the apical term, right? So it's a bit different here then. I'm not sure if
Yeah.
that should be an actual connection that is depicted like this.
Yeah. Yeah. It's a good point, and yeah, I thought, okay, it's kind of because of the connections, and it's easy to spot kind of the symmetries and kind of, but yeah, it's true that this is rather like could be BAP or whatever.
Either
And not
BAP or integrations in the voltage.
yeah,
And the subthreshold voltage.
yeah.
Is there something that needs to be added to the figure if we remove the OTAPs?
Maybe we could include an arrow from the soma going there along the dendrite or something, just to show that there's electrical coupling or something. But I mean, we could also, in principle, we could also take it out. Yeah, I think it's more correct to have nothing than to have it. That's true. Thanks, Martin. And we could indicate some, yeah, but we could also just leave it.
Yeah, I also wonder about the feed forward. I mean, the feed forward neuron goes to a interneuron, which would then, well, presumably be a Paval positive interneuron, because it's one that receives a feed forward projection. But that should not go to the, well, it might target partly the basal dendrite, but mostly the perisomatic region, right? So that's so it's a bit confusing actually. What is a positive, or I don't know whether there are such things as positive error dendrites and negative error dendrites.
Yeah, I
So
agree. It was there in the initial version. So I thought, okay, let's keep it to say that there's these alternatives. We could also, in principle, um, uh, just talk about error computation, because in principle you don't need it at the dendrites in this way. And yeah,
I mean,
it might also be interesting.
Martin, I mean, in the original figure from the dendritic proposal, I think there were concepts like these, right? I mean, I don't think there needs to be negative or positive dendrites, but they could act as one for certain times and change later on. Like it's just the result of the computation locally is that you get a positive error in the dendrite and a negative in another, and that can change for another stimulus. I think that was the intent. Do you agree, or?
yeah, it can be. It's just a bit. It is a bit
And
confusing in the sense of just not being, well, doesn't correspond to physiology, but that's
the fact that that you disagree or that you think, I mean, that should be in the text, but just highlight the challenge of those models with the physiology. But I think they intended to have the pyramidal cells represent the prediction in the soma, and then through the integration across the dendrite, whose error will influence the somatic output. So in that sense, a PV cell that touched the soma would likely modulate the prediction, not the error. And so you would just assign different roles for different inhibitory subtypes than the one you might are thinking. Do you see what I mean?
It's just that this distinction to positive and negative error. In principle, you have both at the dendrite, because the voltage can deviate in both directions from a set point. So in that sense, I mean, we include them into the error neuron theories, because then you just have spiking output, and it's not so easy to do that, like positive and negative signal with that. But with the dendrites, in principle, you do not really need it. So yeah, you can have something that looks like a negative or positive error neuron response if you would have this from the soma, if you would have one type of coupling or the other. You can in principle have negative feed-forward inputs and positive predictions in these theoretical models, and they will give you different behavior of the prediction neurons. But it's this proposal of having, let's say, dedicated negative and dedicated positive error neurons. We didn't do that in the TINs. I don't know, is there another framework that proposes this, or?
There is a figure later on in the manuscript that described dendritic ideas, much later.
Mm-hmm.
So you can check.
Right.
But the intent of this figure was to highlight that the errors will be computed in the dendrites.
Mm-hmm.
And so we have to represent it somehow. If you don't think we should convey the idea that those dendrites are dedicated to specific sign, we should be careful on how we layer that, because I think Keller's work is assigning specific sign to specific neurons that stay with them, which might not be the case here.
Yeah.
Isn't it actually the apical part that you would deem sort of like a negative error dendrites? Because this is where the top down, if the top down is strong and you have little activity, so you have a small leak term, then you will actually see strong activity, right? So sort of in an analogy to the negative error neuron, isn't like that actually? I mean, because you have a positive error dendrites are the basal ones, and the negative error dendrites would be the apical ones, right? Because or
Yeah, it's
if you look
we
at
do
the
have
equations, right?
yeah. It's as you have, with the top down coupling differently than the bottom up here. It's the same with the apical, and it's kind of sign burst. I'm just thinking if, because it can also go in both directions again, and I'm just but it's true. Like here, the prediction is subtracted, and here the prediction is driving. So in a sense, it is a different sign of the effect. But again, the dendrite the error computation can go in both directions. So I wouldn't call it a negative dendrite either. So maybe we can just color these in. Here now we have before we had the label positive, just error neurons for violet. I would rather have these just as error computation, so violet.
I see.
And maybe we can have a separate color also for the positive here, and then adding this. Then we could have the violet here as the, let's say, abstract error neuron, and or we do the same thing as we planned in this figure, having them by So both colors, it's positive and negative error computation happening.
I think I would advocate to have in the legend had it sign error, and then you assign it to A and B, like this color, and then you do the same in E, so that it's clear that you don't expect a specific assignment. And as Martin said, if you expect errors to be in the apical as well in the proximal dendrite, I think that should be reflected. Otherwise, it's going to confuse people.
Yeah. Okay, then I'd suggest we use that color for the unsigned error, assigned error, sorry, for A and B and E as you suggest, and then we color both the basal and the apical dendrites.
I see.
The different causal effect of predictions one can see by either direct drive or drive through the interneuron. And maybe I would just delete this part here.
And maybe we want to have feed forward inhibition and feedback inhibition in the panel E, so more in the apical dendrite as well as the proximal. Do you see what I mean?
Yeah, I know what you mean. In the TILs we wrote that we're not sure if there's really an explicit inhibitory coupling necessary, because it's you literally just need the signal of the neuron itself at these apical dendrites. So it is, maybe we could discuss it in the text whether there is really but originally we didn't propose an interneuron here just for the basal, because here you also need the inputs from other prediction neurons. If that's clear.
Do you feel you need more time to think about it, Lucas? Maybe I'm just curious.
I think I would I could send another proposal and then we collect feedback. But in principle, I would take out the inhibitory neuron, the feed-forward inhibitory neuron, color these dendrites in the general error, like signed error unit color, and yeah, only have the interneuron onto the basal dendrites.
Is it a recurrent? Is it a recurrent inhibition or a feed-forward inhibition that you want to keep?
The recurrent one.
Okay. Well, let's try that.
Okay, then then we had the these parents, and then I'll try to incorporate the feedback, and then if I miss something, we can.
To be sincere, I'm just getting quite a bit more confused by this panel. The more you talk about it, the less clear, right? Because initially I thought that it was a very clear prediction, because at the moment, the way you're actually planning to modify the panel, I'm not even sure that the name for the feed forward to be prediction rather than error is correct. Right? Because if the neuron is going to subtract its own activity, if the main circuit is going to be a feedback inhibition, isn't that kind of the equation hallmark of an error? Because what makes this circuit so different than all the others from my perspective is the fact that in standard predictive coding, the main things which are moved are going to be errors. Right? The communication between areas is generally done with errors.
Right.
And I'm still somewhat surprised by both the circuits in D and E, where the main things which are pushed, at least in this particular case in the feed forward, is going to be the prediction. But in this case, you only pass predictions. Right? So I'm just trying to make sure that the names match the equations. So I think it would be, I'm very much with Martin on this, that just make the circuit match the equations and then it's fine. but also make the names match the equations.
So you're referring to E or
E. If the main part of the circuit is going to be you get a feed forward on a dendrite, then the neuron projects to an inhibitory neuron, which inhibits itself.
Yep.
Isn't that the hallmark of an error?
It is, but it happens at the dendrites.
But then if the neuron integrates a set of errors, why is it the integration of errors called prediction?
Because the output is the prediction. It's the latent variable that predicts the input. So that's the because I mean in the sense you have the same thing in the predictive coding. So they're mathematically equivalent and yeah, but it's the prediction that's output.
Yeah, you're right. Sorry, just naming the follow-up. And one proposal for the colors. Potentially use yellow and red for positive and negative. And if you just want things which are undecided errors, use orange in between.
Let's see what I think. I would trust because there's also like a colorblind aspect, but we have to take into account.
Yep.
So Benedict can explore different colors, and then we'll see what.
I think there's always this maybe commenting on Stefano's comment that there's always a confusion between representation and prediction, right? Because in the classic Raw-Ballard model, you have representational units, you have error units, and you have predictions. So, for example, here in panel E, in a strict sense, something only becomes a prediction once, or the feed forward becomes a prediction once it's actually converted into, for example, the lateral inhibition, right? So it is the lateral inhibition that is predicting the incoming representation and generates an error. But the feed forward signal itself is not yet a prediction, it is a representation, right?
Yeah.
So just like, the neuron itself doesn't predict itself, it is just its own representation is subtracted as a lead current. And so the top down is predicting that directly, but the feed forward input is a representation of the world, right?
Right.
And it gets converted into a prediction. So that solves for me a little bit that representations indeed don't flow forward. Oh, sorry, predictions don't flow forward, but representations of the world do. But they are converted by interneurons into, there are predictions about those inputs from the local interneurons, right? So it's the local circuit that predicts the incoming representations from each level through negative feedback, through inhibition, and that results in feed forward error signals on the dendrites.
Sorry, the connection.
Representation. Yeah, I'm in a train, so sorry.
Could you just repeat the last two sentences?
I would call the feed forward a feed forward representation, and I would call
we lost Martin at its best. I'm sorry, Martin.
Representation is a good suggestion. And
I can try to read his mind from where he was going logically to call feed forward the representation and the feedback a prediction. I think that was the rest of his sentence, but let's hear it. I think he's going to put it in an email to be more precise.
That's right.
Yeah.
Let me write
Yeah. That's a good idea.
Okay.
Regarding, because we were talking about the names already, for the non-hierarchical, how would you propose we deal with the naming convention here between B and D? So I like the idea to have this rather like lateral arrows and yeah, I don't know, Stefan, what your thoughts are on the best solution there.
I do think that we should just follow whatever was the proposal, whatever is called in Keller's paper. That should be the name. Shouldn't be necessarily as our name, because we are reproducing theory. We are reproducing existing theories, right? So this is not what we think it's working, but rather here is what people have stated. So let's just use the same names.
Yeah.
I like the name lateral, because if you have no hierarchy, what's up and down, if you're non-hierarchical, but if that is the terminology which was used, let's stick with it.
Yeah, I think they use bottom-up input and maybe top-down prediction. And for B, you would also use these terms, or
use the terms which are in the paper, in their paper.
Because they, in principle, they don't have arrows. I mean, they don't specify these things, so we have to fill this gap a bit.
That so I actually think they specify that it's both errors and predictions which move in both directions between areas in the non-hierarchical version. That was, I double-checked that last night.
Okay.
They directly specify that, because when creating that figure, I just wanted to make sure that it's to the law, to the letter of what they said.
Could you maybe send me the quote or something, just so that I know the wording that they use?
Can give me 30 seconds to find it. I will show it.
Yeah, no worries. Can also send it later.
Right.
Okay.
Okay. Here. This is from their paper.
Maybe it stops sharing.
Please, and there is associated text. So in here, the prediction is blue, the error is red. And what they present for non-hierarchical are two equally level sensory systems.
Okay, perfect. Yeah.
Okay.
And we use that. These terms.
Have we exhausted the topic, or?
Yes, we're good.
Yeah.
So are you, Lucas, are you going to incorporate the feedback today and then send boost to Benedict?
Yes, I would post it in the discussion as well.
In the discussion, you mean the text, or?
So in the on GitHub.
Oh, I see.
So
that works. You can post it on GitHub, and and maybe next week we can just quickly show the updated figure and make sure that it's all good. Okay, and then next week I would like to share a bunch of tables that we're going to use to help people analyze the data. So we may be able to discuss that next week. So it's going to show all the modalities status where we are, and we want internally to use those tables so that everyone can follow our progress and also see which data is ready to analyze a little more clearly than what we've done so far. So what I would love to happen next week is that we go over those tables and have a discussion on how to organize the analysis as a group, with inputs from any of you. Yes, Alex, if you want to help there, it would be great to organize this effort. But I would bring up the analysis table and then we can go from there. Any other questions or comments? Okay. Well, let's regroup next week. Thank you.